Okay, you should have finished the review up through number 4 and have this idea of how to find the greatest common factor. That's a key thing that we're looking at. Okay, for this note and for this section, we're looking at the idea of trying to do this concept called factoring. And so right now we're going to look at finding the greatest common factor, not just of two numbers, but two monomials. Remember, monomials would be one term. So here's one term, here's one term. We want to know what is the greatest common factor of these two terms. To do it, we do it in parts. First, we look at what we call the coefficients, the number in front of the variables. And so in this one, we have a 21 and 14. So the first directions ask us to find the greatest common factor of 21 and 14. That comes from the coefficient here and coefficient here. So on our calculator, we can do that. If we can't figure it out on ourselves, we go to Math, over to Num, down to Greatest Common Divisor. We want the numbers 14, oops, I guess it was 21 first, so I'll type 21 first, comma 14. Hit enter, and you find that the greatest common divisor is 7. Okay, now we're going to look even more in detail to these two monomials. This one is 21y squared, this one is 14xy. So we looked at the numbers 21 and 14, found their common factor, the greatest common factor is 7. Now we're going to look at the variables. Here I have a y squared. So expanding y squared means I have y times y. Here it asks me to expand xy, so that means I have an x times a y. There's nothing to really change there. When we look for greatest common factor, we look at the biggest amount that they have in common. Looking at this first set of variables, as I look for the greatest common factor of the x's, there's no x's here. There's one x here. The biggest amount they have in common is none. There's no x's in the first term. Looking at the y's though, here I have two y's, here I have one y. The biggest amount of y's they have in common is this y with one of those y's. They both have a y, so the greatest common factor of the y's is one of the y's. Okay, now putting all that information together gives us the greatest common factor of both of these monomials. Of the numbers 21, 14, their common factor is 7. Of the x's, there's no x in the first term, there's one x here, so there's no greatest common factor of x's since there's none in the first term. Then looking at the y's, they both had at least one y. So one y is part of my greatest common factor. Okay, 7y is the greatest common factor of these two monomials. Okay, we're going to continue on. We'll try that again. So if that didn't make entire sense, that's okay. We're going to keep going and look at this next set. So for our next two monomials, they have a coefficient which is 1, nothing written. But they have x's and y's. So first it asks me to take the first monomial and expand out the variables. So x to the fifth means I have 5 x's multiplied together. X to the third means I have 3 y's multiplied together. Okay, that is expanded form of x to the fifth times y to the third. Okay, similarly for my second monomial, I have x squared y to the fourth, so I have x squared, 2 x's multiplied together, y to the fourth, 4 y's multiplied together. To find a common factor, I have to figure out what's the biggest amount of factors they have in common. And so looking at the x's, the greatest common factor of the x's, here there's 5, here there's 2. The biggest amount they have in common, well, there's 2 x's here, and I can circle 2 x's over here. That's the largest amount they have in common. I can't circle any more of these 5 because then I'd have to make circles of x's on the right, and I don't have any more to circle. So there's 2 x's, or an x squared, that they have in common. Now let's look at the y's. Here there's 3 y's, here there's 4 y's. So here all 3 of these y's have a matching y in the second monomial. There's 3 y's here. I can't circle anymore, so I can't go with more than 3 circles. And so I have 3 y's in common in both of these two monomials. So I could do y cubed. So the greatest common factor of these two monomials has an x squared, because that's the biggest amount of x's they have in common, and a y to the third, because that's the biggest amount of y's that they have in common. Okay, our goal again is to say what's the biggest amount that I can divide both of those by. So they have to have the same amount of x's or y's or whatever variable you're working with in order to have that as a common factor. Okay, let's try a couple more. For number 3, we have the monomial 10a cubed b and 15a squared b cubed. Switch to variables of a's and b's. We have coefficients to work with. So first thing we have to do is find the greatest common factor of 10 and 15. Okay, why don't you take a moment, pause the video, go onto your calculator and find the greatest common factor of 10 and 15. Okay, hopefully you found that greatest common factor as 5. Okay, now we're going to look at the variables. Take a minute, I want you to do the expanding step. Expand a cubed b, expand a squared b squared, or b cubed. So pause again, write that expansion out. Okay, hopefully you have 3 a's multiplied with 1 b, and here we have 2 a's multiplied with 3 b's. When I'm finding the greatest common factor of the variables, I need to have the largest amount of a's that I can have that are in both of the monomials. And so here's 3, here's 2. 2 is the smaller amount, so 2 is the biggest amount common factors that I have in each of the monomials. There's 2 here, there's no more, so I can't make more than 2 circles of my a's. And so I have 2 a's in common, so I have an a squared as my common factor for the a's. Okay, now we have to look at b's. Looking at my b's, here I have 1 b, here I have 3. The biggest amount of b's that I have in common is 1 b. Okay, each monomial has at least 1 b. And so I have a common factor of b for my b's. Okay, putting that all together, we have the 5 for the monomial, or for the coefficients. We have the a squared for the a's. We have the b for the b's. Writing that out says I have 5 a squared b as my common factor. Okay, let's continue on and do one more, and then I'm going to have you try a little bit on your own. So looking at number 4. Now I'm finding the greatest common factor of 3 different terms. Okay, we want to find the greatest common factor of 12a cubed, 18a squared, and 9a. First, we're going to look at the coefficients, 12, 18, and 9. Okay, we want to find the greatest common factor, so we go to Math, Num, down to greatest common divisor, and we want to find the greatest common factor of 12, 18, and 9. That's what I was afraid of. All right, so we have to do only 2 at a time. So let's take our 2 smallest numbers. Okay, so we're going to find the greatest common factor of 12 and 9. If I work with that, I hit enter. The greatest common factor of those 2 is 3. Let's check and make sure that divides our largest number as well. Does 3 divide 18? That's our largest number. And it does. Okay, greatest common factor of our 2 smallest numbers is 3. Checking it with our third value, we see 18 is also divisible by 3. And so therefore 3 is our greatest common factor of those 3 values. Okay? Use the smallest 2 to start. Now, it doesn't have us expand, but let's see if we can determine the greatest common factor of the a's without expanding. Okay, I look at the first term, there's 3 a's. I look at the second term, there's 2 a's. I look at the third term, and there's only 1. We have to be able to circle the same amount of a's from all 3 of those. The smallest amount of a's we have is 1, and that's over here. So I'd only be able to make 1 circle in this one. So that means I can only make 1 circle in all 3 of them, and so we just have 1a as our common factor. And so we get our common factor of 3a.